Welcome. Today we're going to learn a strategy for doing multiplication of two numbers that are near 100. So this is a two-digit multiplication strategy for problems like 98 times 87, where both numbers are near 100. Now first I'm going to do this the traditional way, just to show you how it works, or remind you how it works. First you do 7 times 8, which is 56. You write the 6 in the ones column, you carry the 5. Then you do 7 times 9 is 63 and add the 5, which is 68. You write that in. Now you're done multiplying by 7. You put your placeholder 0 there, and you work on multiplying by 8. 8 times 8 is 64. Now we're going to carry a 6. 8 times 9 is 72, and we add the 6 to get 78. And then we take these two numbers and add them together. We get 6, 12, carry 1. This would be 7 and 8, 15. Carry another 1, and we have 8,526 as our solution. That's the right answer. It works. It's a lot of steps. We had about 4 multiplications to do. We had to do all these additions. We had to worry about carrying and being careful up here when we carried. And then we had to be organized about how we write the numbers down so we can obtain the right answer. But of course, this strategy always works. The unfortunate thing is it's a lot of steps, and it's not very conducive to being able to do 98 times 87 mentally in your head. So I'm going to do the same problem, and the first thing I'm going to do is show you the shortcut, which we call Nicolum multiplication below 100, because obviously these numbers are below 100. And first thing to recognize is, if I were going to do 100 times 100 as just a reasonable estimate of what this ought to be, then I will get 10,000. And so what I know about this answer before I start is that it's going to be a little bit less than 10,000. So I'm expecting a 4-digit result. Okay? So we know that. And I'm going to erase this just to get it out of the way. Alright, and what we're going to do, the strategy is over here, right to the right of my numbers, I'm going to write how far they are from 100. So 98 is 2 less than 100, which is why I put the minus sign, and 87 is 13 less than 100. And my first step is going to be to go crosswise and do 87 minus 2, which is 85. And then my second step is to come down and multiply. 2 times 13 is 26. And magically, you can see I have the right answer. I got it in 2 steps instead of several. And my 2 steps were extremely simple. One was a basic subtraction, and the other was a basic multiplication. So the likelihood that I'll make a mistake is much, much less using this strategy. And once I have this strategy committed to memory, and I've used it a few times, I can actually start to do these completely in my head. Okay? So that's how Nicolum below 100 works. And I'll do one more example just to show you, again, to make sure it's all clear. Let's do 95 times 85, for example. Okay, again, on the right, I write down how far the numbers are from 100. That's pretty easy. I go crosswise and subtract to get my first 2 digits. 85 minus 5 is 80. And I come down and multiply, and 5 times 15 is 75. And that is my answer in 2 steps. 8,075. 95 times 85. So that's pretty cool. Very cool strategy. Now, the next question is, why does it work? If we don't understand why it works, we're not going to be able to remember this process because we're not going to use it every day. And then it's really no use in having memorized it. So let's start with a rectangle. We'll make the rectangle 100 by 100. So it's actually a square. So this may not be perfectly to scale, but just imagine that this is 100 times 100. Okay, and of course the area of this square is going to be 100 times 100. And that's why I like to use this model. It's called the area model. And then I'm going to be a little bit clever, and I'm going to make a little slice right here, and another one right there, Okay, and remember the problem that I'm trying to do is 98 times 87. That was the one we originally did. Okay, we're trying to do this problem, and we're going to imagine that I've cut this now into 98 and 2. The whole thing adds up to 100, and 87 and 13. Okay, and then what we know is if we can find the area of this upper left-hand rectangle, that is the area, or excuse me, that is the product of 98 and 87. That's what we're looking for. Now we already know we solved this problem. It should be 85, 26. So I'm sort of going to write that up in the corner as a reminder of what I'm trying to get. And we're going to look at this. So a lot of these areas are very simple. The area of the whole thing is 100 times 100, which is 10,000. Right? We did that already. And the area of this slice right here on the right-hand side, all the way from top to bottom, it has a width of 2 and it has a height of 100, so its area is 200. Okay? And we're going to subtract that because we want the area of this rectangle. We're going to subtract this out. Okay? And then we need to subtract out this stuff at the bottom. So let's subtract out this rectangle, whose height is 13 and whose width is 100. Well, that's easy. That's 1,300 more that we need to subtract out. Okay? Now, we've subtracted this little section twice. Once from here and once from there. So we need to add it back. And the area of that is 13 times 2, or 26. We need to add in 26. So if we could do all these steps quickly, we would have the solution to our problem. Start with 10,000, subtract 200, subtract 1,300, add 26. So let's see what happens when you do that. When you subtract 200 from 10,000, you get 9,800. And when you subtract another 1,300, you get, when we combine these two steps, you get 8,500. And then you add in the 26, and you get 8526. So what we did when we did Nicola multiplication is we did all of that, but we just did it really efficiently because we wrote down minus 2, minus 13. We went across, we said 87 minus 2 is 85. Well, look, and we could have just as easily done 98 minus 3, excuse me, 13. Sorry, 98 minus 13 and gotten 85. And if you look at it, here's our 9,800. Here's us subtracting off 1,300 more, right? And then, when we put the 26 on, that is us adding on the 26. So I have quickly and easily done all this work, backtracking from 10,000 to the right answer, really quick, using my little Nicolim strategy. Because basically I looked at this and I said, hey, this is kind of like 9,800. Subtract 1,300 to get 8,500. And then add back 2 times 13, which is 26, and I get my solution. So this is a little picture that shows what is actually going on when we do 98 times 87. We're leveraging the fact that the numbers are close to 100 and that 100 times 100 is 10,000. And then we're subtracting our way back to the answer. Okay? So that's how Nicolim works. And now you basically know everything you need to know about doing Nicolim multiplication. So let's go over a couple special cases. Suppose we're doing 99 times 98. Okay, these are near 100. I can use Nicolim. Whoops. This is 1 less than 100. That's 2 less. When I do 98 take away 1, I get 97. So I know it's 9,700 and something. And then I do 1 times 2, and I get 2. Now, this answer has got to have 4 digits. It's got to be 9,700 something. So when I get 2, I actually have to put a placeholder 0 there to make things work out. If I didn't put that 0, I might erroneously think the answer was 972, but that is just way too small to be correct. So we have to be a little bit careful when this multiplication ends up being a one-digit number. I need to put in a 0. And then there's another situation where this multiplication ends up having 3 digits. So let's see if we can figure out one of those. How about 80 times 85? Okay. Now we might choose a different strategy to do this problem, but let's just say we wanted to do using a Nicolum. This is minus 20 from 100. This is minus 15. When I subtract like this, I get 85 minus 20 is 65. So it's going to be 6,500 and something. And when I multiply 20 times 15, I get 300. Now 300 doesn't fit. So now I have a carry into the hundreds column. And I usually do that this way. I put the 3 there as a subscript to the 5 to remind myself that those two go together. And then the 100. So it still looks like 300, but what I'm really doing is I'm going to add the 5 and 3 together and get my final answer, which is 6,800. So those are two special cases for Nicolum multiplication. One where you get a one-digit product and you need to put a placeholder 0, and the other where you get a 3-digit product and you need to do a little carry. Okay? And those are really the only two special cases. Now, the last question we need to review is, when does this work and when doesn't it work? Well, the truth is, it always works because it's always using that picture that we showed with this area model to do a quick way of doing subtracting and adding back the little corner rectangle. However, it doesn't always work well. So let's take another example. 75 times 53. Okay. Can we use Nicolum? We can. This would be 25 less than 100. This would be 47 less than 100. And I can do 53 minus 25, which is 28. And I have 2 digits here to work on. And then I have this multiplication. Now, 25 times 47. That's not so easy to do in your head. So this is not a good choice for using Nicolum. But I'm going to do it anyway just to prove that it works. So 25 times 47, I'm going to have to do that over here on the side because that's not so easy. And I'm going to do it real quick. It would be 800, 940 plus, well, let's just do it. I'm going to do 25 times 47 over here on the side. We'll just do a traditional standard method. 7 times 2, 14, add the 3, that's 17, 0, 20, I'd carry a 2 there, 4 times 2 is 8 and 2, 10, that is 1,175. Now I've got this weird carry where I'm carrying 1 here, 1 there, 7, 5, the answer is 3,975, and that's the answer. Let's check it to make sure it's right. 75 times 53. It seems about right because 75 times 50 ought to be about 3750, but let's double check. All right, so 3 times 5 is 15. Carry the 1. 3 times 1, 21 and 1, 22. 0, 25. Carry a 2. 5 times 7, 35 and add 2, 37. Add these together, 3, 9, 7, 5. So, did our Nicolum process work? Yes. Did it require us to do a whole extra math problem over here that was complicated? Yes. Would I recommend this strategy for this problem? No. So the moral of the story is, if you can see that this multiplication over here is going to be easy for you, then Nicolum is a good strategy. If, on the other hand, it comes out to be something fairly complicated, then Nicolum is a bad strategy and we should look for another tool in our toolbox to solve this problem. So that's basically all you need to know about Nicolum below 100.